In the last class, we discussed about inheritance. What do you mean by inheritance and different types of inheritance we seen with the different programs. So, in continuation to that, actually, inheritance is a part of object-oriented programming. We are discussing about object-oriented programming concepts in Python. So, in continuation to that, let me see. Uh, so, let me show you the last topic so that we continue with that. So, in the last class, the class 6, the multiple inheritance we completed. So, before that, we discussed about single inheritance, multi-level inheritance, and in class 6, we discussed about multiple inheritance. Okay. So now in continuation to that, we'll go with other types of inheritances. So we'll see hierarchical inheritance. So what do you mean by hierarchical inheritance? Already we've seen three types of inheritances. One is single, multiple, and multi-level. So in hierarchical inheritance, here it is having different levels. So hierarchical inheritance is nothing but the classes will be there in the form of a tree. So it's follow the tree structure. It's follow the tree structure. So what is the meaning of this tree structure? The tree structure is nothing but, for example, let me give some simple example, and later we'll go for programming implementation. So for example, if you have any uh, you want to write a letter to your principal. So if you want to write a letter to your principal, directly you are not supposed to write. You are not supposed to interact your principal. So that's why you will write a means address your principal, but directly it's not going to be directly went to principal, right? So instead, it's going to your HOD, and HOD is going to forward to principal. So here there are different levels. The level is nothing but first you must you must direct to your HOD, and HOD is going to forward it to principal. So let me explain how this hierarchical inheritance is going to look like. So I have some class here. This is class 1, and this is class 2, class 3, class 4. Again, it is having different classes. So if you see here, it is in the form of a tree. So this is the simple structure of hierarchical inheritance. So here we have this, we can say it is a root node, and this root node is connected with various childs. Again, in each and every level, again we have separate childs. This is, if you see this is looking like a tree. So this is what we can call it as hierarchical inheritance. So if you see here, each and every level, we can say it is a level 1, so highest level. So in our tree terminology, it is what we can call it as root node. Okay, root node is nothing but the topmost node, and next we have left child, right child, and next we'll have childs for the next level, and so on. So the hierarchical inheritance is going to follow the tree level architecture. Okay, or if you want to have some simple architecture, maybe I'll give you the simple architecture also. This is little bit of with more number of levels. But if you want to draw some simple architecture, let me take some simple. This is level 1 and this is level 2. Here I have various levels. So this is nothing but simple architecture of this hierarchical inheritance. So here this is a derived class and this is derived class. From a single parent, we have three derived classes are there. Okay, so here I can consider this A as a base class. And B is a derived class. And C is a one more derived class, and D is other derived class. So here, so these are the different derived classes derived from. If you see here, these are here we have various derived classes derived from A. So this is a simple architecture for hierarchical inheritance. Okay. So now we'll see how this is going to be implemented in a program. Okay, so now we'll go for implementation part. It's part of the tree structure. And the implementation part for this. So now I'll declare some base class here. So class A is my base class, and here I can define some function. So here I can define F1. F1 is my function in the base class, and already we know each and every function in every class. The default parameter will be self, and I'll write some statement here. Print this is parent class. This is parent class function. Next I'll have. I'm trying to implement this architecture. This last one. Just I'm going to implement this last architecture. This one what we are trying to implement. This one. Okay. So for this only I'm going to write a program. Just I declared base class A, and now I need to declare three derived classes. This demonstrates the concept of hierarchical inheritance. So now I'll define if this is what we can call as parent class. Parent class. Now I'll have child class 1. Okay, so in child class 1, I'll define class B, and the class B is it's derived from A. So I'll define a function define F2. In F2, just I'll write print this is child class 1. Child class 1 function. This is child class 1 function. And next I'm going to derive. Okay, so this is child class 1, and next I'll define child class 2. Child class 2, I'll define function F3, and this F3 I can write something. It is second child class, and this is second child class. So now I left the main program. So far, what we did, we implemented this DCD. If you want, you can derive one more class also. I can define one more class. So here, child class 3. Child class 3. So class D, and here we'll derive this. Define F4 self. So print third child. Third child class function. So now I defined base class first A, and from this base class I derived a class B, that is I can call it as child class 1. Next I defined one more class C, and that class C is the next derived class, and the class D is the third derived class. So this is the concept what we are trying to implement. So this concept we are trying to implement. So this is nothing but hierarchical inheritance. Okay. So hierarchical inheritance means we are having multiple levels. Okay, we are implementing this with multiple levels. So this one we are implementing in program. So A is the base class, and B is the derived class, and C is also derived class, and D also derived class. So from A we have one derived class B, and one more derived class C, and one more derived class D. If you see here, this is nothing but in the form of a tree structure. So if we consider A is like a root node, and B is a child, and C is a child, and D is a child. So if you go for some more complex program, maybe you can go for this type of architecture also. This is also hierarchical inheritance structure only, but it is little bit complex. So we are not going for complex example. So just we are trying to implement the simple example. So that's why we are going with this. Okay. If you want, you can implement this example later as a homework. You can consider, and you can implement it. But the thing is, okay, you must incorporate the hierarchy, means various levels. Okay, now I defined 4 classes. A is a base, and B is a first child, C is second child, and D third child. Now I need to write the main program. In main program, already we know if I want to access something in inheritance, in general, I can access by using the derived class object. If you see here, B is a derived class, and C is a derived class, and D also a derived class. So for a single base class, so here base class is A, and we have different derived classes for this base class. Okay, B, C, D are the derived classes, right? So for this, I need to create an object. So I can create object O is equals to, I can write obj is equals to, I can create object for B. Okay, and I can access the information of B and as well as A. So here obj dot f2. What is this f2? F2 is a function in the derived class B, and with this object I can access the f1 also. What is f1? F1 is a base class, right? Or f1 is the parent class. So if we see here, B is derived from A. B is derived from A. So that's why I'm creating an object for the class B. So I'm creating an object for class B. So object name I given as OBJ. So OBJ is the object I created for class B, and with the help of this object, I'm trying to access the functions in class B and as well as in class A. So class B function I'm trying to access first, that is F2, and class A function also I can access. How can I access class A function? Because class A is basically it is the base class. So that's why already we know in inheritance the main use of inheritance itself is reusability. Once we defined something in parent class, we can access that parent class information with the help of derived class. So that is what I am trying to do here. So here the parent class is A and derived class is B. So here that's why I am trying to access the information of this parent class of derived class. And similarly, I can create one more object obj1 is equals to, now I can create an object for this second child class. What is second child class? C. Okay. So and I can access this obj1 dot f3. This is a function in second child class, and I can access obj1 dot f1. What is the meaning of this? What is the meaning of these three lines? If you see this diagram, so if you see this diagram, A is the base class. With the help of class B, class C, and the class D, I can access the information of class A. So that's why first I'm trying to access the information of class A with the help of class B, and next I'm trying to access the information of class C. Okay, with the help of class C, I'm trying to access the information of class A, and finally I'm trying to access the information of class A with the help of D. So if you see here, these three are the child classes, right? So this one, B is a child class, and C is a child class, D is a child class. So with the help of B, or with the help of C, or with the help of D, I can access the information of class A. Why? Because B is derived from A, and C is derived from A, and D also derived from A. So that's why I can access the information of the parent class with any child class. I can use B, or I can use C, or I can use D. Or maybe I can use B, C, D. With the help of B, C, D, I can access this parent class information. So that is what we are doing in this program. So what I am doing here with the help of B object, I am trying to access F1. What is F1 actually? F1 is a function in class A, or F1 is a function in base class. So here I am doing same here also. What is this? Again, I am trying to access F1 with which object? I am trying to access the F1 function with the class C object. What is class C? Class C is nothing but it is a second child derived from parent A. If you see this diagram, class C is the second child. Class C is the second child. Class B is the first child. And the class D, we have one more class D that is also derived from A. So if you want, you can write that one also. So now what I need to do, I can create an object for obj2 is equals to D. So this is object I created for class D, and with the help of this object obj2 dot f4. What is this f4? F4 is a function in class D. If you see here, in class D, we have a function f4. Okay. So with the help of this class D object, I can access class A information also. So now I can access class A information obj2 2 dot f1. I'll write the comment also so that you can understand. So here what I'm trying to do, this first point is this is accessing parent class with the first child class. I'm trying to access this accessing parent class with first child class B. So this is the first child class. B is the first child class. And similarly, you can access the accessing parent class with the second child class. What is the second child class here? That is C. Next. Here I am trying to access this with the third child class. What is the third child class? Third child class is C. Okay, so this one is D. So B, C, D are the derived classes. With the help of these derived classes, I am trying to access the base class information. So that is the implementation of this hierarchical inheritance. So let me run this program. I'll explain if anybody having any doubts. Hierarchical. Okay, so now if you see this program, so what is this program output? First is this is child class 1 function. So child class 1 function is okay. And what about this one? This is parent class function. So this parent class function I am trying to access with the help of this child class, that is B. Next, second child class function. The second child class, the second child class I am trying to access parent class. So this is accessing this parent class with the help of B. Next, these two lines are accessing this parent class with the help of class C, and this one is accessing this parent class with the help of class D. So that is nothing but a inheritance. So if you have any doubt, please let me know in the chat box if anyone having any doubts, because this is one of the important type of inheritance. If anyone having any doubts, please let me know in the chat box. Do you understand or not? So please send me if you have any doubts in the chat box. Please communicate in chat box if you have any doubts, or at least if you understood or not, you try to comment in chat box so that I'll proceed to the next topic. Any doubts so far? Did you understand first? Please respond, everyone. 50 students are there. Everyone, please respond in the chat box. Because if you understand this, then only the next type of inheritance, that is hybrid inheritance. So in hybrid inheritance also, we are going to use hierarchy in hybrid. Please respond in the chat box. Don't get any response so far. Already it is enabled. It is enabled. You people, please type something in the chat box if you understood or not. If you didn't understood, please let me know where you didn't understood so that I can explain once again, or maybe I'll go with the next topic if you people understand. Question also. That's why I'm asking you people whether you are getting or not. Everyone, please respond. Only one student is responded so far. Sai. Remaining students, ask. Remaining students, ask ma. I'm not asking any question. Just I'm asking whether you understood or not. Especially the concept and the program, because to understand the program, then it is very difficult. So that's why remaining students, okay, so hope most of you are understand. Okay, next topic is next topic is the other type of inheritance. So this is an example program for hierarchical inheritance. The next type of inheritance is hybrid inheritance. Hybrid. So what do you mean by hybrid inheritance? Hybrid inheritance is nothing but, actually there is no specific definition for hybrid inheritance. So it is a type of inheritance where we can use the combination of any two types of inheritances. Okay, I'll explain what is the meaning of this line. Hybrid inheritance is nothing but it is a type of inheritance where we can use the combination of any two types of inheritances. Okay, so what is the meaning of this? For example, if we use single inheritance with multiple inheritance. Okay, so here actually in a single example, in a single application, I'm going to use single inheritance with multiple inheritance. So if you see here, this is single and this is multiple. So that is what I'm trying to explain. If you are trying to use the combination of any two types of inheritance, combination means it may be single with multiple, or multiple with multi-level, or multi-level with hierarchical. Okay, so any two types, you can combine any two types of inheritance. So that is going to be called as hybrid. There is no specific combination for a hybrid. It may be any combination of two types of inheritance. You may use single with a multiple, or single with a multi-level, or multi-level with a multiple, or multiple with a hierarchical, or hierarchical with the single. So all are comes under hybrid only. Hybrid means what? It's not from a single type. For example, you may heard about hybrid mangoes or a hybrid fruits. Okay, so that is what do you mean by hybrid? Hybrid is nothing but it is not from a single seed. Okay, in terms of fruits or in terms of okay, flowers, or in terms of different objects. Hybrid means it's a combination of different classes. So for example, I have a rose flower. Okay, a simple rose plant is there. That rose plant is giving more number of rose flowers. One rose plant is giving more number of flowers. I have one more rose plant that is giving less number of flowers, but it's giving very colorful flowers. I have two rose plants. One rose plant is giving more number of flowers, but these flowers are not colorful. Second rose plant is there. It is giving very less number of flowers, but it is giving very colorful flowers. So my objective is I need to have a rose plant which is going to give more number of flowers, and at the same time the flower will be colorful. Okay, so how can I do this? I can do this, or I can get this hybrid tree or a hybrid plant with the help of these two. So that is what hybrid is all about. Hybrid is you can take combinations, different combinations. So nowadays we are getting a hybrid, different types of hybrid seeds. Hybrid seeds. What do you mean by hybrid seeds? Hybrid seed is nothing but you can take the seed which is going to give more profit and which is going to take less time. So you can combine these two seeds and you are going to generate a new hybrid seed. So that is what hybrid is nothing but it's simply taking different combinations so that we get the better output. Here also say hybrid means we can have different types of inheritance. Any two categories, any two different types of inheritance, and that is not it's not like it's only have single and multiple, single and multi level. It's not like that. You can take any type of inheritance, but it should be combination of different. Okay, so I'll give some simple example so that you can understand how it is going to be implemented. Because if you want to understand these hybrid inheritances, you must be familiar with all the topics what we discussed so far. Means all the types of inheritances. If you know all the types of inheritances, then only you can understand this hybrid inheritance. Okay, so let's I have some example. So I can take some class. I can take some class here, and this class is deriving two more child classes, and again it is going to derive two more classes. Okay, and I going to have this. So from it is deriving two classes, and it is also deriving two more classes. It is also deriving two more classes. Okay, and with the help of this, it is deriving. So now see here, I can call it as the this is class A, and this is B, and this is C, this is D, this is E, this is E, and this is F. So now if you see here, so C is derived from A. Okay, C is derived from A, and D is derived from A and B. If you see here, so C is derived from class A, and this D is derived from class A and B. Okay, so just I'm going to use the concept of different types of inheritance. If you see only A and C, I can consider A and C. It's a single inheritance. Only A is the base class and C is the derived class. Only one base class and one derived class. I can consider this as a single inheritance. If you see this A, B, and D, so A, B is a two base classes are there, and D is a one derived class. So this is other type of inheritance. So that's why there is no specific definition for this hybrid inheritance. Only the meaning, the context here is we'll have types of inheritances. They will be combined or they will be merged so that you are going to get a new type of inheritance. That is what we can call it as hybrid. You can take any two different types and you can combine it such that you will get the other type of inheritance. So that is nothing but a hybrid. Let me give some simple example implementation program for this so that you can understand how it is going to be implemented. Okay, so I can take some base class. I can call it as A. So here I can define f1, my function here. So this function I can write print this is base class function. So now I can derive a derived class B, and it is derived from A. Okay, so in this I can derive a function f2. So in this f2, I can write print this is derived one. Next, I'll have class C, and this class C also derived from A. So here I can define f3. Print this is derived. Next, I'll declare one more class D. So here what I'll do is I can take this A and B, or I can take B comma A. So here I'm going to take two classes. Let me explain this diagram diagrammatically so that you can understand what I'm trying to do here. So F4 enter. This is another class derived from A and B. So this is the class, and for this class I'll design the diagrammatic implementation so that you can understand. So now I'll have so I first A is there, that is a base. A is a base class. I'll have A. So this is base class. And from A we are deriving B and C. From A we are deriving B and C. So here I can derive B and C. So this is B and this is C. So B is derived from A and C also derived from A. Okay. And next what I am doing here, if you observe here, D is derived from B and A. So D is derived from B and A. So D is derived from B and A. So from this, I can derive B and A from B and A. I can derive this from B and A. So this B and A are deriving class D. And C is derived from A. C is derived from A. So this is what hierarchical with the combination of multi-level or the combination of single. So this is hybrid. Why it is hybrid? If you see here, you can find different types of inheritances here. It is not a single inheritance. It's not only one type of inheritance where we can find different types of inheritance. So if you see here A and B, only with the A and B, okay. So A and B. So here actually A and this B is derived from E. So now if you see only this A, B, C, if you observe this A, B, C, then observe this three classes A, B, C. So A is a base here, B and C are different. Okay. See A, B, D. If you see A, B, D, then so A, B, D, if you see here, A is a base and from A, B is derived, and again A and B are going to combine the deriving B. So it's a combination of different inheritances. So that's why it comes under hybrid. Okay, as I mentioned, hybrid means there is no specific definition for hybrid, and we can't say like only okay, this is the only hybrid form, means it's not like that. Okay, I given one more. This one also hybrid only. The only thing is if you are able to incorporate more than one type of inheritance in a particular application or in a particular concept, that is what we can call it as hybrid. If you are able to incorporate more than one type of inheritance in a particular application or in a particular problem, that is what we can call it as hybrid inheritance. So these two examples will come under hybrid inheritance only, or you can write your own example also. The only condition, the only rule you need to remember in hybrid is it's a combination of any two types of inheritance. Okay, there is no like it's going to take only multiple and multi-level or single and multi-level or single and hybrid hierarchical. It's not like that. You can take any two types. So that is about hybrid. And I'll come to this program and I'll create the main program here. I'll create a main program. In main program, just I'll create object for last class, that is B. So I'm creating object for class D, and I can access obj dot f1 and obj dot f2. I can access these two functions, obj dot f1 and obj dot f2. This is hybrid inheritance. Okay. So this is base class function and this is derived one. So here what I'm trying to do, I'm trying to access this base class and as well as first child class. Derived one means first child class. I'm trying to access the base class and as well as first child class from the last class D. Okay. This is an example for a hybrid inheritance. So any doubts so far in all types of inheritances? So this is the last type of inheritance. So if you have any doubts, please let me know. And if you don't have any doubts, then we'll go to the next topic. So we started with the object-oriented programming concepts in first class. We seen what is class and some examples for classes, how to create a class and how to create an object and what do you mean by inheritance and different types of inheritance we've seen. We started with single inheritance, next multi-level, next multiple, next hierarchical, and a hybrid. Okay, we see four types of inheritance. Any doubts? If anyone having any doubts, please let me know. In all the topics what we covered so far in advanced Python, we completed all the types of inheritances and the classes and objects. Any doubts, please let me know. Any doubts, ma? If you don't have any doubts, then we'll go to the next topic, that is polymorphism. That is also very important topic. Any doubts so far? All these object-oriented programming concepts are very, very important because these all are new concepts. Okay, it's not like we derive two classes from one base. How it is called? It is means hybrid means very simple. It's not like okay. You are supposed to demonstrate any two types of inheritance. There is no specific rule. Actually, if you are going to derive two classes from a single base, means it is comes under uh, hierarchical actually. In hierarchical, if you see in the last example, that is hierarchical only. In a hierarchical, actually I took three childs. Maybe you can take only two childs also for a single base class. Okay. Hierarchical means it's in the form of a tree. For example, we don't know how many childs a root will have. I considered three childs in the last example. If you consider two childs, that is also comes under hierarchical only. The only thing is you are supposed to demonstrate in the form of levels. It may be two levels or three levels, doesn't matter. Okay, so any doubts? If we don't have any doubts, then we'll go for polymorphism. Is function name also case sensitive in oops? No, yes, function name is a case sensitive, not function name. Python language itself is a case sensitive. Whatever, whether it is advanced Python, core Python, whatever it may be, entire Python you need to maintain case sensitive. Okay, it's Python itself is case sensitive. Whether it is a function, whether it is a class, whether it is a variable, whether it is a constant, anything, it will follow the case sensitive rule. Okay, it's not only for any function or class. In the entire Python, you need to follow the case sensitive rule. Okay, so I hope everyone is clear with this inheritance. So now I'll go to the next topic, that is polymorphism. So already maybe you heard about this polymorphism somewhere in your Java or in C++. Polymorphism. Okay. What do you mean by polymorphism? Anyone can define polymorphism? Because it is not a new concept. It is already there in C++ or Java. If you studied C++ or Java in your regular semesters, so already maybe you heard about this word. Just I'm asking, what is the meaning of the word polymorphism? Of course, it is one of the very important object-oriented programming concept. Okay, so polymorphism is nothing but simply the definition is the ability to take more than one form. Okay, this is a simple definition of polymorphism, the ability to take more than one form. What is the ability to take more than one form? I'll give a simple example. Very simple example. For example, you're having a laptop. Okay, so to carry your laptop, you're going to use a bag, laptop bag. When you purchase any laptop, obviously the company people are going to give you laptop bag, or if they won't give, you are supposed to purchase it. Okay, so is laptop bag will be used to only carry laptop, or it can be used for purpose. For example, if the purpose bag is to carry the laptop, that is okay, fine. But for example, you are going for your relative's house, okay, and you want to stay 2 days there. You don't have any bags. Then maybe you are trying to use the laptop for carrying your clothes. Here, purpose of the laptop, in general, the laptop bag purpose is to carry only laptop. But now you don't have any other bags available to carry your clothes. You may use the same laptop bag for carrying your clothes also. So here, that is what ability to take more than one form. What is more than one form? In general, so far used it for what is the purpose? Purpose is to carry laptop. But now the same bag you are using for some other purpose. What is the other purpose? Other purpose is to carry your clothes. For example, the same bag may be used to carry your textbooks also. For example, on one day, for example, you are having examination in your college. You are going to write exam. So when you are going to write exam, you are not supposed to carry your laptop. Laptop is not required on the day of examination. Instead of carrying a laptop in that bag on examination day, you may carry your textbooks of that particular exam, or you may carry some notebooks of that particular exam in the same bag. So now if you see, the same bag will be used for multiple purpose. One purpose is you can carry your laptop. Second purpose is you may carry your clothes. And third purpose is maybe you can carry your textbooks or notebooks. So this is what we can call it as polymorphism. The ability to take more than one used to carry your laptop, but also it will be used to carry your clothes, and also it will be used to carry your textbooks or notebooks. To use in polymorphism in object-oriented programming concept. Let me give simple example. For example, I have a function called add. So it's going to take two arguments, 2, 3, and I have one more function add. It's going to take some other argument. And I have one more function add. It's going to take some other arguments. So now all of you please see here. What is the name of the function here? Name of the function is add only. In these three cases, name of the function is add only. But is it taking same type of arguments every time? If you see this line, this is going to take pure integer argument. 2 and 3 are integers. And if you see here, same add function is going to take 2 float arguments in the second in the second line here. And if you take the same add function, it's going to take string arguments. Okay, but if you observe these three cases, is the function name is same or different? The function name is same. Function name is add, and it is going to be used for different purposes. That is what same example I explained for laptop also. Okay, laptop bag is same. The bag is same, but it will be used for different purposes. One time I'll use to carry laptop, and maybe other time I'll use to carry textbooks, and other time maybe I'll use to carry my clothes, or maybe other time I'm used to carry the vegetable. Okay, are the different purposes. So here also, if any function, okay, that function is going to take different types of arguments, but the name of the function is same. The function name is same. What is the function name? Add. It is same, but it will be used for different purposes. That is what we can call it as polymorphism. Okay. The function is in this case. In this case, so here I'll write down the above example. The above example function, the function add is used. Add is used for different purposes. Okay, so first purpose is with the integer arguments. And second purpose is with the float arguments. Float arguments. Third purpose is with argument. Okay, and at the function name see here function name is add, but it will be used for different purposes. This is the concept of polymorphism. I'll give some simple examples in shell. In ideal shell, I'll give some simple examples. Okay, so that you can understand. Okay, so here I'll write some simple examples on shell polymorphism. Okay. So use function for different purposes. For example, length of hello. That is giving 5. Next, length of is giving 3. Next, length of so now see here, what is the name of the function? len. Len is the name of the function, but one time I'm using some string argument, one time I'm using some list, and one time I'm using some tuple. And of course, you can use some other types also. You can use some dictionary, use some sets. But here the concept is, if you see, the name of the function is len only. So this is a simple example for polymorphism. The function name is same, and it is behaving differently depending on the type of the arguments what we have. Okay. So here the function name is same. So I'll give, this is one more example. Two is function name. If you see here len, and it is doing in different ways, right? If I pass some integer, or if I pass some string, or if I pass some list, or if I pass some a tuple, or if I pass some dictionary, or if I pass some okay sets, it's behaving in all the cases. The function name is len only. Okay, so these are the two examples. I hope you got some clarity on this polymorphism. So just it is behaving in different way, type of the arguments what we are passing. Now I'll try to give some more programming example so that you can understand better. So polymorphism. So now I'll define a function, define some function, add function I'll define. So in add function, I can take A, B, C. Okay. So I can take A, B, C, and I'll write return A plus B plus C. A plus B plus C. Next. Next, I'll pass some value here, 10. Next, I'll write the main program. I'll call this function print of. I'll pass only two arguments. Okay, 100, 200. I'll pass for this function, add function, I'll pass 100, 200. Next, I'll pass print of add, I'll pass 100, 200, 300. Now see here, and I'll take one more function, add of, I can take only some 1000. Now see here, function name is add only, but I am passing two arguments one time, and I am passing three arguments other time, and I am passing only one argument some other time, right? So now if I execute this, polymorphism.py. Okay, so now if I execute this, okay, so we are getting 310, 600, 1510. So if you see this program, So how the same function is behaving in different ways. If you see here, the function is same. I'm not written three functions, right? I'm written only one function add, but I'm sending different arguments for calling the same function add in different ways. So same function add, I'm sending two arguments. Next I'm sending three arguments. Next I'm sending one argument. So this is what polymorphism. Depending on our requirement, we are sending different arguments while calling the same function. That is requirement. You are using the laptop bag in different ways. One way you are using for carrying your laptop, the other way you are using for carrying your clothes, and the other purpose you are using for carrying your notebooks, and maybe other purpose you are using for carrying your vegetables. So these are nothing but our requirement. Depending on our requirement, are we changing? Are we changing the bag? Are we using some other bag? No, we are not using any other bag. We are using same laptop bag, right? The object here is same. Okay, the same object will be used in different purposes depending on our requirement. So this is about polymorphism. Any doubts? Any doubts? Please let me know in the chat box if you have. Yeah, one task is executed in many forms. Yes. Task means here function. Any more doubts? Please respond in the chat box if anyone having any doubts. No doubts. Program not understood. Which program not understood? This program, polymorphism program. Okay, so here I'm trying to use the same function add with the different ways of calling. Here I can use 100 200. So if I use 100 200, this 100 will goes to A and this 200 will goes to B, right? And C value will be 10 only. If I use this 100 200 300, then this 100 will be goes to A and 200 will be goes to B and 300 will be goes to C. Next, if I use 1000, then 1000 will be goes to A and B is 500 and C is 10. So that's why we got the three different outputs, right? What is first output? 100 plus 500 plus 10. 100 plus 500 plus 10. We'll get 610. First output will get 610. Next 100 plus 200 plus 100 plus 200 plus 300. That is 600. Next 1000 plus 500 plus 10. So 1000 plus 500, 1500 plus 10, 1510. So here the concept is not about output actually. The concept is how we are calling a function as per our requirement in different ways. That's why I given three examples like len function name is len only. But if I send some string, it is giving some output. And if I send some list, it's giving some other output. If I send some tuple, it is giving other output, right? So these all are nothing but different ways how we are going to how different ways a function is going to behave. Okay, I'll give one more example how this will be used in object-oriented programming. So this is actually here I did a normal function. I didn't use any class. So now I'll try to use a class and I'll try to explain how this polymorphism can be implemented in with the help of for these classes. Class, I can define some class A. Class A, I can define some function f1. In f1, so I can write print A F1. In class A, it is a F1 function. Similarly, I can define one more function here. DEF F2. In F2, print A F2. In class A, this is F2 function. Right. Next, I'll define one more class, B. Class B. In class B, I can have same function F1, and this is class B F1. Next, I'll have F2, and B F2. So just you see here, just I use the same function names. What is the same function name? F1, it's there in class A, and again F2, it's there in class A. Same function name F1 and F2 are used in class B also. So here F1 is there in class A, and as well as F1 is there in class B, and F2 is there in class A, and as well as F2 is there in class B. So that is what we are talking about. Polymorphism means a function is going to behave in different ways, right? So now I'll start the main program. So in main program, I'll create object for okay. So I'll create object for obj1. Object 1 I'll create for class A. This is object for class A. And next I'll create object 2 for class B. Okay. Next. Next you can write obj1 dot f1 obj1 dot f2 obj2 dot f1 and obj2 dot f2. Okay, so just I created two classes A and B, and I created two objects for A and B. Object 1 is for class A, and object 2 is for class B, and object 1 dot f1 and object 1 dot f2 and object 2 dot f1 and object 2 dot f2. So here the concept is function f1 is used in both the classes, and function f2 is used in both the classes, but f1 is behaving in a way in class A, and same f1 is behaving in other way in class B. So here f1 f2 are nothing but two functions. They are behaving in different ways in both the classes. So if I call this, okay, then we can see what is the output we are going to get in different classes. Polymorphism 2. Polymorphism 2.py. Okay, so here I am calling class A F1 and class A F2, class B F1, class B F2. So here actually I am calling same function F1, but it is behaving in different way in class A, and same F1 is behaving in other way in second class. Okay, If you observe here, these last 4 lines, these 4 lines, just I am calling same function 2 times. F1 I am calling 2 times, F2 I am calling 2 times. But I am calling F1 with a different object, right? Object 1 and F2 with object 1. Similarly, F1 with object 2 and F2 with object 2. So here the concept is, when I call F1 with object 1, it is behaving in some way, and when I call F1 with object 2, it is behaving in other way. So that is what we are talking about, polymorphism. Depending on the type of the argument or depending on the requirement what we have, the function is going to behave in other way. So that is what polymorphism is all about. Any doubts? Please let me know if you have any doubts. This length function is predefined. Yes, length is predefined function. Length is predefined function. It is there in all the data types like list, tuple, okay, dictionary, sets. It's a predefined. Any doubts in polymorphism? Please let me know if you have any doubts. Okay, so this is also known as, what is the other name for this? Can anyone name what is the other name for this? A function with a different arguments and it is behaving in different way. Okay, the generalized name is polymorphism. Is there any specific name for this? Can anyone mention what is the specific name for this? What is the specific name for this? Yes, function overloading. Very good. Nirmal. Okay. So function with the different arguments, same function name with the different arguments, is behaving in different ways, nothing but function overloading. Okay. So similarly, we'll have in your C++, maybe you heard about operator overloading. Operator overloading means operator is same. Like plus is an operator. I can use plus for different purposes. I can add 2 integer numbers using plus. I can add 2 float numbers using plus, or I can add 2 double numbers using plus, or I can add 2 complex numbers using plus, and I can add 2 strings using plus. That is nothing but operator overloading. And in this polymorphism, apart from this function overloading, we'll have overriding also. Okay, so this is also known as function overloading. Function overloading. Okay, next we'll talk about function overriding. Function or method overriding. Function or method overriding. So what is the meaning of function or method overriding? Okay, so here method name is same and arguments also same. Okay, so in function overloading, in function overloading or in method overloading, in function overloading or in method overloading, the function name is same or the method name. Function or method both are same, don't confuse. That's why I'm writing in brackets method. Method also known as function. Okay. In function overloading or in method overloading, the function name is same, but arguments are different. arguments are different. Okay, that is what we can call it as function overloading and method overloading. And what about method overriding? Method name is same and arguments also same. Let me take some example. Add. I'll have some arguments. Okay, two arguments. So integer arguments. And I have same method add, same arguments, integer. This is nothing but an example of method overriding. Method overriding. So method overriding is nothing but where we are going to have method name, same method name and same arguments. But when this will occur, when this method overriding is going to happen, so that is very important point. Method overriding will happen in inheritance only. Inheritance. Okay. What is the meaning of this? Method overriding will happen in inheritance. So for example, let's say I have a class A. In class A, I have a method. So def some f. It is having some code. I'll have some code. Next I'll have one more class B, and it is derived from A. It's derived from A. And I'll have def f2, f1. So now see here. Okay, so after that I'll write main program. So now I'll create object 1 is equals to, I can create object 1 is equals to some B. For B class I created object. Now I get object 1 dot f1. So all of you please see this part of the code. Okay, this is what we can call it as method overriding. Method overriding means the method name is same and arguments also same. If you see here f1 is a method. So the method is f1 and it is not taking any arguments in our case. But if you see here in class B also we have same method f1. So as B is derived from A, if you see here B class is derived from A, right? So this is what we can call it as, okay, method overriding will happen in inheritance only. What is the meaning of this? So here A is a base class. It is having function f1 and B is a derived class. It's derived from A and B also having same function f1. Now tell me, what is the output of this? Means which function will be called? When I return obj.f1, which function will be called? Is it a base class function or a derived class function? Please respond in the chat box. Both. Okay. Any other answers? Please everyone respond. I'll show you the code once again, but everyone please respond. Because we have same method names in base and as well as derived. What will happen now? Will happen? Please respond. Remaining students, what happened? Ambiguity error. Okay. So anyway, programmatically we'll see the same. But in general, when we have this scenario, when we have the same method name in both base and derived classes, if you are trying to call this function, in general, the derived class method will overrides the base class method. So here, the above example, the derived class method will overrides the derived class method will override the base class method. Okay, so we'll see this example practically how this is going to happen. Okay, so let me write this program. Very simple program. Method overriding. So let me define a class. So here I can write def f1. So here I can write print. This is base class method. Next I'll have one more class B. So derived from A. Def f2. So print. This is derived class method. Okay, so here the method name should be same, f1 only. Okay, now I'll create a main program. Main program, I'll create object. Okay, obj is equals to, I can create object for the derived class. So now I can call obj dot f1. Okay, so this is a question what I asked actually. Method overriding dot py. Okay, so now see here, what is the output we got? Now tell me which method is called? Which method is called? Now please respond, remaining students, which method is called? Did we get any error? Any ambiguity happened here? Okay, so this is the program and it is calling the derived class method. That's why this statement we got as output. This is derived class method. So that is the point I written here in the explanation. That is the point I written here. So what is the point? In the above example, the derived class method will override the base class method. So here the derived class method is going to override the base class method. This is what we can call it as method overriding. Very, very important question for interviews. What is the difference between method overriding and method overloading? Method overloading is method name is same with the different arguments. But method overriding is nothing but same method name with the same arguments. And when method overriding is going to occur, method overriding is going to occur in inheritance only. It doesn't happen in other cases because only scenario when some method is going to override another method, it happens only in inheritance. So if you see here in this example, class A is the base class. We have a method f1 and the class B is derived from A. Okay, and same method f1 is there in class B also. So when I created an object for the derived class B, and if I call f1, so which function f1, which f1 will be called? Is it from base class or is it from derived class? So obviously the f1 from the derived class will be invoked. F1 from the derived class will be invoked. This is what we can call it as. Okay, the derived class method is going to override the base class method. Okay, for example, if you are using some multi-level inheritance, in multi-level, what will be there? You'll have three classes: first class, second class, third class. So third class, if you create an object for the third class, so it is going to override the above two classes, right? So that is what we can call it as method overriding. Okay. So any doubts? Hope all of you are understood, right? Any doubts? This is very, very important topic.